The airplanes you're watching are just one step in man's ongoing fascination with flight. We at Skyward Tech are thrilled by our good fortune to be part of the wonderful industry that supports the efforts of flyers everywhere. Through the years, Todd Johnson and Philip Honick have met with many of you around the world, conducting engine overhaul workshops. They've had the opportunity to hear about your interests and concerns. Your enthusiasm led them to create videos outlining the overhaul procedures for several popular engines. This video continues that dedication to providing you with the best information about your engine. Both Todd and Phil hope that this will translate into a safer and more secure feeling as you take off to experience that unique thrill. Man breaking free of gravity and moving across the sky. While some of you are part of the growing group of home enthusiasts building your own craft, others of you will be like many of the folks Phil and Todd meet around the country, those who want to know when an overhaul is called for and what is involved. Like car owners, some people take special care of their machines while others wait for a problem. With an airplane, maintenance means safety and peace of mind. An overhaul is recommended when you've reached your TBO, time between overhaul recommendation, you've reached the manufacturer's time limit on an overhaul schedule, or an unknown condition exists and an overhaul will ensure your comfort and peace of mind. Additionally, preventative maintenance should be done to the manufacturer's specifications. This tape deals with the Lycoming IO360 engine. You'll note that we continually remind you to consult the manufacturer's manuals for tolerances, torques, and other specifications. Different model years, model alterations, and design tweaking won't change the basics of the overhaul, but they will require you to maintain diligence in attending to the details. So, enjoy the tape, whether you use it to rebuild an engine or just to become more familiar with your engine's internal workings. It's great for honing your skills or just making you a more knowledgeable aviator. Our demonstration begins at Matatuck Aviation, the world's largest engine rebuilders. Located on Long Island, Matatuck Aviation very generously allowed us the use of their facilities to perform our rebuilding. While we're beginning with the reassembly, you have to have completed certain tasks not covered here to reach this point. At this facility, engines are shipped in or actually flown in. The engines are removed, disassembled, and everything is cleaned by water, chemical, brush, or machine. All tolerances are checked, and parts are either brought up to specifications, or if that is impossible, they're discarded and replaced. The reassembly centers around the crankshaft, which we've mounted vertically on a fixed column. A pan collar at the bottom is a convenience. It helps with holding parts and tools. The advantage of this mounting becomes apparent when we need to rotate the engine by hand to position the pistons and perform other timing operations. We also mount the crankshaft vertically so we can visualize the placement of the engine's parts. We understand that this is where the number 1 cylinder will be, the number 2 cylinder, and so forth. This allows us to further visualize the relationship between parts such as the sump, the camshaft, etc. While our engine doesn't have one, some IO360s use a counterweight system as a torsional vibration damper. The counterweight is held in by counterweight pins. A counterweight plate holds the pins in, and it is secured by a snap ring. The first step takes place as a subassembly. The left half of the crankcase is painted with an adhesive. The adhesive is used to hold a 100% silk thread that actually works as a gasket. This thread is routed to the inside of any bolt holes so that no oil can escape through the bolt holes or the parting surfaces. The silk thread is left long so that it will meet and be a continuation of the nose seal that will be used at the crankshaft opening. Next, we put in the bearing inserts. There have been updates in a few different styles of this part, so refer to your parts manual for specific parts numbers. Now, we put in the tappets, which actually give movement to the valve train. As with most assembly steps, everything is lubricated.